Hi everyone, welcome to this lecture. So in this lecture, we are going to solve our project 4 on support vector classifier. That is, we are again going to learn how to perform grid search cross validation using support vector machine. But this time our data set is different from the project 3. So here I am at my project 4. Click on this file so that we can open it in our Google Colab environment. So here I am at my project 4 in Google Colab environment. So for this project, I am going to use a dataset known as breast cancer dataset. So I am going to load this dataset from Scikit-learn.dataset. I also need a NumPy. I need support vector classifier. I need train test split function. I need confusion matrix and confusion matrix display function. I need matplotlib. I need pandas. So let's run this cell to import all these necessary Python libraries. So the dataset I am going to use is a breast cancer data that is present in Scikit-learn.dataset. So it's time to load the dataset. So I am going to load the dataset in the form of data frames. That's why I have written as frame is equals to true. Let's run this cell and see our data. So we can see that we have a big data. We have quite a large number of columns and they are 31 to be exact. So we have 31 columns in our data set and we have 569 rows. It means 569 samples. If we see the last column is a target and it has two different values, 0 and 1. So 0 means the patient doesn't have a cancer and 1 means the patient has a cancer. So that last column target will be used as our labels. Okay, let's check the shape again. So the shape of the data is 569 by 31. That is, we have 569 rows and 31 column. Let's see if there is any null value. So we can see that there is no null value. And all these are the feature. The last column is the target and rest all these 30 values are the features. So we can see that all these features, we will use all these features in order to classify the patient whether he or she has a cancer or not. So these are the value of a mean radius, mean texture, mean parameter. So this is the information about the tumor of a cancer. So we have the radius of the tumor, the texture of the tumor, and all the other information about the tumor of a cancer. And based on these features, we are going to classify the patient into 0 and 1, that is whether he or she has a cancer or not. Okay, since data is clean, there is no missing value, it's time to extract the feature. So I need everything in my features except the last column, which will be used for a labels. So here I am going to extract all the 30 column, except the last. And for label, I am going to extract only the last column. Let's run this cell to extract the value of features and the labels or the target. Here I have the features now. If I see, there is no target column at the last because I have removed it for the feature matrix. So this is my feature matrix. And now in feature matrix, I can see from here, I now have 30 columns instead of 31. Initially, when I read the data, we had 31 columns. We can see from here as well, we had 31 columns. Now the last column was the target column. After extracting the features, I have now 30 features. Okay, let's see the unique value in the target. So we have only two unique values, 0 and 1. 0 means the patient doesn't have the cancer and 1 means it has the cancer. Now it's time to perform the train test split. For the train test split, I am going to use X and Y. That is my feature matrix and my labels. The testing size is 20%. That is test size is equals to 0.2. It means 80% of the data will be used for the training. Let's run this cell to perform the train test split. And now I have the training component, the testing component, the training labels, and the test labels. And now it's time to standardize the data. So this is very standard code. We have seen this code in project 3 as well. So let's run this cell in order to standardize the data. Now it's time to apply support vector classifier. So for support vector classifier here, I am going to use a kernel RBF. I am going to use a value of C is equals to 1, and I am going to use gamma is equals to scale. So here I am training my model on the training component. After get training, I am getting the prediction from my model. Let's run this cell to train and test the model. So these are the predictions of the model. Now it's time to check the accuracy. For accuracy, I am comparing the predictions of the model with the actual test label. Let's run this cell. So we have seen that it's a very high accuracy, that is 98.25% on this large data set. Let's see the confusion matrix. And in confusion matrix, we have seen that there are only 2 samples which are misclassified. All the other samples have been classified correctly. That's why the accuracy is very high, that is 98.25%. Okay, let's try to improve this accuracy. This is also very high. Let's try to improve this accuracy using grid search cross validation. So for grid search cross validation, I am going to use the same code, exactly the same code which I used in project 3. That is, I am passing all the possible combinations of C, kernel, and gamma to my model, and I am training the model on all these possible combinations so that model can provide me the best parameter during the training. Let's run this cell to get the best possible parameter from the model. So the value of C obtained is 20. This is the best value of C according to the model. The gamma is 0.01 and kernel is radial basis function. Okay, now gets the prediction from this model. So these are our prediction and we are calling it YPRED cross-validated prediction. Let's check the accuracy now. So we can see that our accuracy is again 98.25%. So without grid search, our accuracy was 98.25%. And with grid search, our accuracy is again 98.2%. But the important point to remember is the parameters are different. Here C is 20 and the value of gamma is 0.01. And here without grid search, the value of C was only 1 and the gamma was scale. So the reason is that we have already obtained very high accuracy, that is 98.25%. So using grid search, we again duplicate this value. So our model tried very hard and it provided us the best parameter. But even with those best parameter, we are still duplicating the same accuracy. So we have learned that if the accuracy is already high, it is not easy to improve the accuracy with any method when you are close to 99% or 100%. So in this project, we learn again how to perform grid search cross validation using support vector classifier. We use a different data set, that is the breast cancer data set, which we loaded from Scikit-learn dataset. So this was a large data set which have 30 features. So I hope you understood this project. Thanks for listening and I will see you in the next lecture.